Hello everyone, welcome to Trunkie Academy. I am Dr. Pallavi Kulkarni, your chemistry teacher. Just give me a second. Yes, so we are discussing the structure of atoms since this week, and we have finished up to we have started the Bohr's atomic model. So we are going to continue the Bohr's atomic model for today also. So structure of atom or atomic structure, different scientists have worked on this, like J.J. Thomson, James Chadwick, Ernest Rutherford, then Neil Bohr. These are the prominent scientists who has worked on the structure of atom. So we have started discussing the Bohr's atomic model or Bohr's model of atom, right? Now just have a quick recap of yesterday's session, and then we will see the next part. So according to this Bohr's atomic model, every atom has the nucleus. So this is the nucleus, which is centrally located. All the mass of that particular atom is concentrated at the nucleus, okay, because the nucleus contain the two subatomic particles. One is the proton, another is the neutron, right? These two subatomic particles are present in the nucleus of an atom. Protons is positively charged and it has a mass, considerable mass. Neutrons is electrically nil and it has a considerable mass too, right? Whereas surrounding to the nucleus, the electrons are revolving in the circular paths, which are called as shells. So in these shells, electrons are present. Electron is negatively charged and it does not have considerable mass. Its mass is negligible mass, right? Therefore, whatever mass of that particular atom is, it is concentrated in what? Nucleus. It is concentrated in nucleus, right? Okay, inside the nucleus, the protons and neutrons are present. Then surrounding to the nucleus, the electrons are revolving. Revolving means continuously moving in circular motion, just like the atom is spherical entity, just like a football. Just like the earth is revolving surrounding to the sun, the moon is revolving surrounding to the earth. Similarly, the electrons are which can be considered the planet, and the nucleus can be considered as sun, and planets are revolving surrounding to the sun, right? Similarly, the electrons are also revolving. Okay, now as this is a 2D board, I am not able to show the shells or orbits in 3D, right? Therefore I am drawing circle, but I hope you can understand atom is spherical entity, just like a football. It's not flat, it's not planar, it's 3D, three-dimensional. So this is the first shell, you can see first circle. This is the second one. Okay, then next third one, then fourth one. For the understanding purpose or for avoiding the crowding, I am drawing it up to the fourth circle, but that does not mean only 4 circles are present. The number of shells is different than 4, right? It may be 4, it may be less than, or it may be greater than 4. Just for avoiding the crowding on the board, I am drawing only 4 circles here. I hope you can understand. Okay, now let us see the names of these shells. So this is the first shell, which is called as K shell. This is the K shell. The next one is L shell. Next is M shell, and the last one is N shell. Okay, so this is how the shells are given symbol. Similar to the symbol, the shells are also given the numbers, right? Similar to the symbol. So this is what we have discussed in the yesterday's class. Now today we are going to see how the electrons are distributed in these orbitals, right? So that part we are going to discuss in today's class. Okay, so for that purpose I will be using the same image. distribution of electrons in atom. Distribution of electron in atom, that is the topic we are going to discuss. So first of all, we are going to see how the shells, or how these what you can say subshells are located in the atom, right? Okay, so this is the nucleus of an atom. Quick, I'll just draw all these shells one by one. So this is the first shell, this is the second shell, then this one is the third one, and the last one. Again, I am repeatedly telling, just for avoiding the crowding, I am drawing only up to 4. That does not mean only 4 shells are present in all atom. No. Okay, yes. So what is the name given to this circular paths by Neil Bohr? Shells or orbits, right? Okay. Now shells or orbits are having different symbols like K, L, M and N. Okay, these are the symbols given by the scientist Neil Bohr. K, L, M, N, O, P, Q, R and so on, right? Okay, similar to this symbol, he has also given number to them, which is called as shell number. Shell number is denoted by the symbol small n. Small n stands for shell number. K shell is the first circle from the nucleus, so it is shell number 1. L is the shell number 2. M is the shell number 3 and N is the shell number 4. If it is O shell, shell number 5. P shell 6 and so on. 1, 2, 3, 4, 5, 6 and so on. K, L, M, N, O, P, Q, R and so on, right? So these are the shell numbers. I have given you the distribution or division of these shells further into subshells already, right? So that part I am not going to write down again and again. So subshells, for K shell only one subshell will be there, for L 2 subshells, for M 3 subshells, for N 4 subshells, right? Okay, now what are these subshells? For this sequence you have to remember S, S and P, S, P and D, S, P, D and F, right? If it is further O shell, it will be S, P, D, F and G, right? But as I am writing only up to this, I am writing S, P, D and F, right? Okay, so as we know, these subshells are further divided into the orbitals, right? Okay, subshells are further divided into orbitals. Okay, so for orbitals we draw the orbital notation. Orbital notation can be written in 2 ways, and this is the number of electrons. Yes, orbital notation can be written in 2 ways. Let me just show you that to you. So first of all, S orbital, S subshell is divided into only one orbital, no division further, only one orbital. So either you can draw a circle or you can draw a box. Okay, I find writing down or drawing the box easy, so I will prefer. If you find drawing the circle easy, then you can go for it. Okay, so it is a circle, so it is a box or circle, whatever, it's up to you. So for S subshell, only one box stands for one orbital, or one circle stands for one orbital. Okay, yes, so always remember, in every box maximum 2 electrons can be filled. I will repeat, in every box maximum 2 electrons can be filled. Okay, yes, so out of these 2 electrons, one will be like this, whose arrow is pointing upwards. Another is like this, whose arrow is pointing downwards. There is a meaning to this. Okay, so this is nothing but they are having different spins. Okay, they are having different spins. The one which is having upward arrow, it is having the spin 1/2 plus 1/2. Another which is downward, it has a minus 1/2. About these numbers, spin and everything, we are going to learn in detail further. Okay, yes, just right now remember that when you are drawing the electrons in orbital, you should draw it like this. Okay, you will never write it like this, or you will never write it like this. You should draw in such a way that one is upward, another is downward. As in case of S subshell, there is only one box, that is, there is only one orbital. One orbital stands for one box, right? One orbital stands for how many electrons? 2. So number of electrons is equal to 2 for this, right? How many maximum electrons we can fill in S subshell? We can fill maximum 2 electrons in it, right? Okay, after S subshell, next one I will write down P subshell. Okay, for P is further divided into 3 boxes, right? That is for P subshell. How many orbitals are there? 3 orbitals are there. Okay, so 1, 2 and 3 subshells. So let us fill the electron. Now filling the electrons here also has one very important rule. Okay, now there are different ways to fill the electron. Let me just show those ways to you. So first, yes, let me just show. So these are the different ways. Okay, yes, let us see. So first way, like I can fill first of all electrons singly like this, and then I can start pairing. Pairing means what? 2 electrons in one box, that is pairing. Okay, this is the one way. What is that? I'll show you again. First of all, I can fill single electron in all boxes, and then I will start pairing double. So this is how the 6 electrons can be filled. What is another way? I can start pairing from the starting box only, like this, right? I can do it like this, or I can fill the electrons from whatever box I want, right? Okay, so out of these 3, or there may be some another ways also, these 2 are incorrect, whereas this one is the correct way, right? What is the correct way? You should first of all fill all the boxes singly. One electron you have to add. Once all the boxes are with the single electron, with the unpaired electron, then you can again come back to the box number 1 and start pairing onwards. Okay, yes, so this is nothing but, this is one rule actually. Okay, I'll write down the name of this rule, and then I will explain the one simple analogy to remember this rule. Okay, this rule is called as Hund's rule of maximum multiplicity. Okay, this rule is called as Hund's rule of maximum multiplicity. Maximum multiplicity. Okay, what is this rule? Let me write down first of all, and then I'll explain the analogy. Okay, so while filling the orbitals with electron, while filling the orbital, one box with electrons, first of all they are filled with, or they are filled with single electrons in each, single electron in each, and then pairing is started. Okay, and then pairing is started. This is called as Hund's rule of maximum multiplicity. I'll give a simple analogy to understand this. Assume that these boxes are nothing but, okay, let us see, like 5 boxes are there, right? This whole thing is nothing but a bus. Okay, this whole thing is nothing but a bus, and these are nothing but the seats available in the bus, right? So you are waiting for the bus, and you are waiting for the bus at the start point, at the start stop, bus stop, right? From which the bus will go to other stops. So you are waiting for the bus, along with you the other people are also there waiting for the bus to come. Once the bus will come there, as it is a starting point, it will be completely vacant. Bus will be completely vacant as it is a start point, right? Okay, once the bus comes there, what is the usual tendency of people? People will sit on they will occupy the window seats, right? That is the normal human tendency, right? They will occupy the window seats. So all the window seats will be occupied, and then bus will, for example, just consider it will go to the next stop. At the next stop, some more people will enter in the bus, and people will see all the seats are occupied, singly occupied, all the window seats are occupied. So what is the option? They can start pairing, right? So they will start pairing. once all the window seats are occupied. The same thing happens here. First of all these boxes is nothing but the orbitals. All these boxes will be occupied by the one electron each. Once all the boxes are completely filled by one electron, then pairing will start. There is a reason to this. The reason is about the symmetry, right? The reason is about the symmetry. What is the meaning of symmetry? I'll tell you. Okay, assume that this is the one option for filling the electron. Another I'll show you. Okay, another in which the pairing will start from the first box only. In this case, can you see, while we were filling the 3 electrons here like this, and assume 3 electrons are filled in this, and then next slot, right? So here you can see this looks very symmetrical, one electron in each box. This looks very symmetrical. There is a symmetry in this arrangement, while no symmetry here, right? One box is containing 2 electrons, one contains only 1, another is completely empty. So there is no symmetry in this arrangement, right? Therefore, always, symmetry gives the stability to all the species in matter in nature. All the types of matter in nature, they want a symmetrical arrangement, right? Okay, so symmetry gives stability. Therefore, this is the preferred arrangement and not this. Okay, you understand? Therefore, remember Hertz's rule of maximum multiplicity. Whenever you are filling the electrons in the orbitals, first of all, this is not only for p orbital, remember. This is not only for p orbital, this is true for d, f and g orbitals also. For those orbitals also we are going to do the same thing. We are going to first of all fill the boxes by single electron, then we can start pairing. Okay, yes. So how many maximum electrons we can fill in p block? 6 electrons, right? 6 electrons. Okay, then we'll write down for d orbitals now. So d orbital is further divided into 5 boxes, right? One box, one orbital. Okay, one, 2, 3, 4 and 5, right? Again here also I will use the same rule, Hertz's rule of maximum multiplicity. What is that rule? First of all, occupy all the window seats. Okay, all the window seats have been occupied. Then start a pairing. Okay, then start a pairing, right? So how many maximum electrons we can fill in d orbital? 10, right? 5 boxes, 10 electrons. 10. Then again we can do the same thing for f orbital, right? Okay, for f orbital, how many boxes are there? There is a simple trick to remember the number of boxes here. You can see the number of boxes are 1, 3, 5, 7, 9, all odd numbers. Okay, so that is a simple trick to remember the number of boxes. If you remember number of boxes, you can remember number of electrons. Number of electrons are 2 multiplied by number of boxes. Okay, yes. So f will have 7 boxes, right? 1, 3, 5, 7, 9. Okay, then 1, 2, 3, 4, 5, 6 and 7. One, 2, 3, 4, 5, 6 and 7. 7 boxes. Again Hertz's rule of maximum multiplicity you are going to follow. First of all, occupy all the window seats like this. This is really very important. Why I am telling you repeatedly? This is going to help us in writing down the electron configuration of atoms. Okay, you need to know electron configuration for class 9. We need to know how to write down electron configuration for at least first 20 elements. Okay, yes, that's why learning this is really very important. Okay, then start pairing like this, like this, like this. Yes, so how many total electrons, maximum electron we can fill here? We can fill maximum up to 14 electrons, right? 7 boxes, 14 electrons. And then last I'll explain for g orbitals, right? Okay, again as I have told you, 9 boxes, right? 7, 8 and 9, right? 4, 5, 6, 7, 8 and 9. First of all window seats like this, and then start pairing like this. Okay, so you can see 9 boxes, therefore 9 into 2, that is we can fill maximum to 18 electrons here. Okay, yeah, so this is how the electrons are distributed in the shells, right, in the subshells and shells. Okay, so you can do one thing, so forget about the recap, take a screenshot of this page first of all, Hunt's rule of maximum multiplicity, and then we will see how to distribute the electrons in the orbitals with the help of examples. Okay, actual examples we'll see. Okay, now let us see examples one by one. First of all, we'll start with the simplest example of all. And that is nothing but the hydrogen atom. First example, hydrogen atom. Okay, yes, now as far as hydrogen atom is concerned, H is the symbol for hydrogen, atomic number is equal to 1, right? Okay, so this one will be the nucleus of hydrogen atom, right? Okay, and this is the first shell, that is shell number 1. Okay, K shell. Okay, yes, so in case of carbon only one shell or one orbit is there. Then as we know, maximum electrons that can be filled in shell number 1, that is K shell, can be calculated by using the formula 2n square. This formula yesterday only I have told you. So 2 into 1 square, that will be 2. So how many maximum electrons we can fill in shell K, that is first shell? Yes, 2 electrons. But hydrogen has only 1, so no question about it. So that 1 electron I will fill here like this. Okay, so this is the structure of hydrogen atom. This is the structure of hydrogen atom. Now what will be its electronic configuration? Its electron configuration means the distribution of electrons in the atom. Okay, electron configuration will be like this. So for that purpose you need to remember one simple formula. What is that formula? So this is nothing but electron configuration is written like this: N, S, and here X. Okay, yes, so what is N here? Or instead of S I'll write down another thing, N, then Okay, S I'll write down, and then here I'll write down X. Okay, where N is the shell number or orbit number. Okay, shell or orbit number. Okay, what is S? S is the symbol of the subshell. Symbol of subshell, that is S, P, D or F, right? Symbol of the subshells, S or P or D or F is the symbol or G also. Then X is the number of electrons in that shell. X is the number of electrons. Okay, yes, so this is how electron configuration can be written. So let us see for hydrogen atom. So in case of hydrogen, the electron is present in the first shell, shell number 1, right? Okay, inside the bracket shell numbers is written. Okay, yes, what is the shell number? N is equal to 1 for hydrogen, right? N is equal to 1. Okay, yes, let me write down here first of all. For hydrogen, N is equal to 1. Okay, as only one electron is there, as we have seen this sequence S, P, D and F, right? The same sequence you have to remember. K shell has only one subshell, S subshell, right? So no question about it. So what is the subshell? Subshell symbol is also S. And what is the number of electron? Electrons are also equal to 1, right? Okay, therefore what will be electron configuration? 1, then S, and in the subscript you will write down the number of electron 1. So 1s1 is the electron configuration of hydrogen atom. Okay, so 1s1 is the electron configuration of hydrogen atom. Okay, 1s1 is the electron configuration of hydrogen atom. Okay, yes, I hope you understood this example. Let us see one more example so that it will be more clear. Second example I'll write down, and that is nothing but helium. Okay, helium atom. For helium, He is the symbol, atomic number is equal to 2, right? Atomic number is nothing but number of electrons. Z is atomic number is equal to number of electrons, and it is also equal to number of protons, but we are not talking about proton here, we are talking about electron configuration. Okay, therefore how many electrons are present in helium? 2 electrons are present. Okay, yes, so this is the nucleus of helium atom, and this is the first shell, that is K shell. Okay, yes, so shell is K shell, that is first shell, and maximum electron that can be present in that shell is 2n square. N is equal to 1, so 2 into 1 square is equal to 2. Maximum to 2 electrons we can fill in the K shell. Okay, let us start filling. So this is the first electron, this is the second electron, so that's it, right? In K shell we can fill 2 electrons, so no need of L shell further for helium also. Just like for hydrogen, there is no need of further shell because only 2 electrons are present. What will be electron configuration then? So N is equal to 1, the subshell is S, and number of electrons is 2. So electron configuration will be 1s2, right? Hydrogen was 1s1, helium is 1s2. Okay, so what is 1s2? It is the electron configuration of helium atom, right? Of He is the helium atom. Okay, yes, now let us see the next example. With the next example, the idea of electron configuration will be more clear to you. Okay, it is lithium. Okay, lithium symbol is Li, atomic number is 3. So how many electrons are present in lithium? There are 3 electrons in lithium, right? Number of electrons is 3. Okay, yes, then this is the nucleus of lithium atom. Shell number 1 I will draw. Okay, this is shell number 1. Shell number 1 is nothing but the K shell. Okay, so this is yes, so this is the shell symbol and maximum electrons that can be filled in that particular shell. Okay, so first is the K shell. The shell number is 1. Maximum electrons is 2 into 1 square, that is 2. Okay, so in first shell we can fill 2 electrons. Let us start filling 1 and 2. Okay, 2 electrons are filled, but what about the third electron? In lithium, one more electron is there, so we need to think of that electron. So where that electron will go? Obviously it will go in the next energy level, right? Which is the next energy level? L is the second shell. Okay, in second shell how many maximum electrons we can fill? 2 into 2 square, that is equal to 8. So we can fill maximum to 8 electrons there. Let us start filling then. So this is the second shell of lithium, in which we can fill the third electron. Only one electron is there here, therefore no question about it. So third electron we will fill here. Do you understand? So when the shell is completed, that particular shell is completely filled, its capacity we can find out by using the formula 2n square. Then you have to enter the next electron to the next shell. Okay, that was the idea here. So yes, so for this, when you are writing down electron configuration, you have to write down electron configuration for this circle first and then for the second. So first of all I will write down for the K circle. For K circle, okay, what is the for K shell, what is N? N is equal to 1. What is S? Symbol for subshell is S. And what is the number of electron? In K you can see 2 electrons are there. Yes, and there another, and for L shell, right? Okay, for L shell we know symbol, the L symbol number, shell number is 2. And here also for L also, can you see the sequence? You have to always keep constant, S, P, D and F, right? So first of all S for L shell. Now this S is for L shell, right? There are 2 S. So first S is for shell number 1. Now second S is for the shell number 2. Don't get confused, right? Again start with S. Next shell start with SPDF. Next shell start with SPDF. Sequence should be same. In this, how many electrons are there? Only 1. So X will be equal to 1, right? Now you are going to write down the configuration for both these separately. I will write down first of all K. So for K it will be 1, then S, then 2 in the superscript. This is for K. And then for L also I will write down 2, then S, then 1. No need to write down 2p because only 1 electron is there, right? So do you understand? So this is your K shell and this is your L shell. So this is nothing but electron configuration of lithium atom. Do you understand? So in tomorrow's class we are going to see how to write down the electronic configuration for the next elements with the higher or greater atomic numbers or number of electrons, right? Slowly we will reach up to atomic number 20. Okay, once you understood the idea, then writing down electronic configuration is really very easy task. Okay, yes, so that's all for today. Yes, you have taken a screenshot up to this. Start taking the screenshots from these examples. First for hydrogen. Yes, take the screenshot for hydrogen. Then for helium. And then lithium, last example. Okay, I hope this concept of distribution of electron is clear. In tomorrow's class we will see the next examples with the same concept. I hope it is clear to you. If you have any questions, please let me know in the tomorrow's session. Okay, yes, so let's see the DPP, that is daily practice problem. So this is a teacher's portal, similar is the students portal also. Go to the resources, then to the writing material, and open DPP, that is daily practice problem. You will see the questions over here. Write down the solutions and answer on your notebook. Take a photograph of that solution and just upload it on your portal, so that teacher will be able to evaluate and let you know the suggestions and corrections wherever required. Okay, so that's all for today. Next part we will discuss in tomorrow's session. Thank you so much, students, for your precious time, and thank you so much for joining.